Good morning, geometry. Hey, guess what we get to start today? Chapter 19. And the section we're going to look at today is section 19-1, where we're going to look at some solid figures and do some cross sections on it and rotations and just look at it from a perspective of three-dimensional. All right, so now the essential question for this section is, what tools can you use to visualize solid figures accurately? All right, now this one's going to be really interesting. Again, if you can see three-dimensional, you'll have absolutely no problem with this section. What I want to do is just do a few examples. It's not a hard section. And what it's going to come, I think it's going to come in two parts. All right, so the first one is looking at what is called a net. And a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. Now, in other words, it's just like getting a box. Okay, and if you take a box and open it up and flatten it out, you'll be able to see the flat out portion of the box. That is called a net. It's just a picture of what the geometric shape looks like when it's been flattened. Okay, very applicational in the real world, very applicational in the area of engineering. I'm telling you, you'll be amazed as to how companies design boxes or containers or cans. It's all mathematical. Okay, so what we're going to do today is, in this part, is we'll do the explore. Okay, so what we're going to give again is they're going to give parts of it and they're going to skip some parts. Like here is a rectangular prism. It's like a box. Okay, now if you take this box and flatten it out or open it up, it'll look like this. This here is the net of the rectangular shape, the rectangular prism. Okay, now a type of solid this is, you can tell by looking at it, it's a rectangular prism. And also some information from a rectangular prism. It has three pairs of congruent rectangles. What does that mean? Well, again, we know the front side and the back side of the geometric shape are congruent. The left side and the right side of the geometric shape are congruent. The top and the bottom are congruent. So again, this is what it's telling you. So what we're going to do is, throughout this section, is you may get a rectangular shape and we may have to make a net of it. Or you're going to get a net and you're going to have to draw or picture what the solid looks like. Okay, so let's look at our next one. The next one, they only told us that we're dealing with a rectangular prism, and it also says it has a pair of congruent triangles and three rectangles. All right, so if you stop for a moment, we know it's a rectangular prism. So I did my best of drawing. Again, I didn't make it perfect, but I drew a rectangular prism, a triangular prism, to give it the appearance of a three-dimensional look. All right, now, if we take this triangular prism and open it up, it will look something like this. Now again, what we got to do as time goes on is, if we look at this shape, can we get it to look like this? Now again, you can do this a couple of ways. You can make get yourself a sheet of paper out, draw the net, cut it, the whole diagram out, fold it along these lines, and it should look like this. All right. Now this one is drawn differently than this one. Okay, so it's going to take a little bit of practice. So that is what we're doing in this chapter. It's relatively easy. All right, here we go. Here's the next one. Here's our net. Okay, and if you look at it, it says it has a rectangle and two pairs of congruent isosceles triangles. Now remember, isosceles triangles are two of the sides have the same length. Okay, so if you look at this, this is our net. Again, if we were to cut it out, fold it along these edges, it will look like this. And this would be an example of a rectangular pyramid. So let's look at the next one. The next one all they gave us is a cylinder. Okay, they told us that the type of solid is a cylinder. What would it look like as a net? Well, from looking at this, we know it has two congruent circles, the top and the bottom, and it has a rectangle. So in other words, if you were to take this is almost like taking a can, and if you were to cut the tops off and cut along along the height of that spherical, the round part, it will look like this if we were to make this as a net. Now again, the way this diagram's set up, it doesn't matter where you put these guys, the two circles. You could have put them up here. It doesn't matter. Just the whole picture here is, can you look at a net and determine what type of solid it is? So that's what this section's all about. All right. Again, I didn't draw it accurately. I just threw it together. All right. Now the next thing is doing it by looking at the geometric solid, identifying cross sections. So in other words, okay, recall that a cross section is a region of a plane that intersects a solid figure, and cross sections of three-dimensional figures sometimes turn out to be simple figures such as triangles, rectangles, or circles. Now again, what they're doing here is one example. Here is a a cylinder, okay? And what they did is they just imagine this is a saw, they sawed it in half. That's what they call a cross section. We could have done it this way, we could have done it vertically, it doesn't matter, okay? Let's see what's next. The next one, they have, if you look at this problem, the lateral surface of the cone curves in the horizontal direction, but not the vertical direction. Therefore, the two sides of the cross section along this surface are straight line segments with equal length. What does that mean? No big deal. If you could look at this here, this is a cone. And if they just take the cone and just sliced it in half, again, if we were to look at that image going this direction, it's going to look like this. Just to give you guys an idea, okay? It's just going to look like this. It's going to look like a rectangle. That is if I'm taking this figure and I'm looking at this direction, okay? But what if we were looking at it in this direction? Well, if it's looking at this direction, we'll better label it. This is 1, okay? And we'll call this one 2, so you can see it. And what does it look like in that direction? Guess what it looks like? It looks like this. All right. So this is some people can see this, some people can't. So again, we're going to do the best we can. All right, let's go down here. I didn't do this one that much. Here is a cylinder. Describe each cross section of each figure. Again, I'm not going to. It's really no big deal. Okay. All right, let's go to generating three-dimensional figures. So in other words, if we were to go back to this shape right here, and if we were just given this or this as the view of what it is, can we put together a three-dimensional figure? All right, so here we go. Example 2A. All they give us is this right here. And again, you have to do a little bit of imagination. What would this look like if, again, you see see this here? This is your line. What would this geometric figure look like as a three-dimensional figure? Now, again, to do that, again, here's our line. So what we'll probably need to do is take that line or that geometric shape and rotate it around that line. And what would it look like? Well, that's what it would look like. Let's try another one. Here, all they gave us here is a rectangle. What would it look like as a three-dimensional figure? Once again, if we take it and rotate it around this line, it will look like that. It'll look like a cylinder. Again, down below here is just the information about it. This is the description part of what we just done. I just showed you what it looks like if you just rotate it. That is, let's try another one. All right, let's see. I think what I'm going to do is, if you go to, let's move my calculator because we don't need it today. All right, ready? Here's the year turn, number 5. Here is our geometric shape. It's a trapezoid. It has 4 sides. 2 of the sides are parallel. Okay. What would this figure look like as in 3-dimensional? So again, you take it, rotate it around your line. Okay. All right, now then, if you were to make it shape, now I did not draw it neatly. This is what it would look like. That's what the 3-dimensional look will look like if I take a geometric shape and rotate it around a line that's been cut through. Okay? Almost looks like a top. So that is basically what we're going to do. Now this one down here, again, just rotate it about this, and guess what it's going to look like? That one's going to look like a sphere. Oop, spheres. Why did I make it plural? Who knows? My eraser's not working. It's also for those of you that it's not only is it a sphere, but it's also looks like a ball. All right. So that is what section 19-1 is all about. Not that difficult. Very little math involved. It's just taking a geometric shape, looking at it, whether it is a net or putting it into a net, okay? Or in other words, taking a geometric shape and taking the box apart and laying it out flat. That's what they would look like. Or what does the geometric shape look like if we rotate it around some line? All right, that is what section 19-1 is all about. All right, that's it on this video. Tomorrow the next video will be section 19-2, and I'll catch you later. Bye.